Welcome to video 20 on Fun with Arduino. We have been working on LEDs blinking, servo motors rotating and sensors detecting a train, and it's time to put it all together now in one big piece of code to get a working railway crossing. And that's exactly what we are going to do. So here's the complete cycle. The train is coming and it's detected by the first sensor. The lights are blinking, the gate is closing. Of course the train is moving along the track already. Gate is fully closed, and then we reach the exit detector and then the gate opens again. This is what it is supposed to be, and now let's have a look how we can put this all together. The LEDs, the servo and the sensors. Looking at the state transition diagram, we need a construction with 4 states, a switch state. Case 1 is the idle state, case 2 is the LEDs are blinking. Then in state 3 the gate is closing, and then in state 4 the gate is opening again. Also we need 4 transitions. Well, let's just make them and don't even think about what exactly we need to do here yet. We will fill it in later. This is just the framework and that is ready now. In this next step we are going to fill in the events that trigger a transition from one state to another. If we are in the idle state, then what we are going to do is wait for the train to trigger sensor 1. If we are in the blinking state, then we are going to wait until it is time to close the gate. If we are in the gate closed state, then we are going to wait for the train to trigger sensor 2. And when the gate is opening, then we are going to wait until the angle is the fully gate open angle. That means that we can stop blinking and we return to the idle state. It's all quite straightforward, easy steps. Let's have a look at the transitions now. In the case of transition 1 to 2, obviously a train has now been detected and we should start blinking. Well, that is quite easy. We just say blink enabled is 1. And also at the same time we already set this time in the future, time to close the gate, that is the current clock plus the gate delay, such that that is already running. That's all for this transition. Let's go to the next. Transition 2 to 3, that is the situation where it is time to close the gate. That is again quite easy. How do we close the gate? Well, we have our servo motor set point and we set it to the gate closed angle. There's not more to it than that. The next transition, state 3 to state 4, that is the gate is now closed and we are waiting for the sensor 2 to be detected. And if it is, then we are going to open the gate, which means we have to make this set point for the servo the gate open angle. And then the servo will start to turn, and then finally we have our last case, and that is the gate is now completely open. So we print out that fact and we also say we are now idle and again waiting for a new train. And of course in the process we stop blinking and we make both our LEDs 0. That's actually all that needs to be done inside these states. Now we still have to take care that our servo is going to move and that our LEDs are going to blink. To move the servo we use our millis clock. If it is time to move the servo, then we set our future moment in time to be the current clock plus the gate speed that we defined at the top of the code. Then we check where the angle is with relation to the set point, and we either increment our angle or decrement our angle. And finally we write our angle to our servo. There's not much more to it than this. For the LEDs something similar is happening. But it is encapsulated. That there's the similar construction with the millis, which is checked for time to blink, and then we set our future time to blink to be the current clock plus the blink speed. We set our two LEDs and make them inverse to each other, and all of this is encapsulated in this check that says if blink is enabled. If it is disabled, then we don't even do all this, of course. And finally we write our two LED values to the digital pins. And then there are still some defines and some declarations to do. Let's have a look at. Here we are at the very top of our code. We define a gate speed. That is the milliseconds between servo steps. So a smaller number means the beam, the servo, will move faster. We have the gate delay. That was the time between sensor 1 was triggered before the beam starts to move. I have put that on 4 seconds because that looked similar to the prototype. Then we have two servo angles that we fine-tuned with our analog potentiometer a few videos ago, and we found that the angles of 60 and 135 were fine. The blink speed is obviously how fast the two LEDs are blinking, and then we have a whole lot of pin numbers, and then we go to our declarations. Of course we have a state and a transition variable, and the state starts at 1. Then we have our two LEDs and the fact if the blinking is enabled or not. Then we have the two angle and set point variables for the servo, which initially are both set to the gate is open. And then we have three of these timer variables: the time to blink, the time to close the gate, and the time for servo movement. Then of course we include the servo library and we define our gate servo. It's just a name, you can give it any name that you would like. Then we have some setup to do. Of course we first make our two sensor pins an input, and similarly we make our two LED pins an output. Then we attach the servo, the gate servo, to the servo pin, and the first action is we write it to the current angle, which was the gate open angle. Then we do some serial printing to tell us on the PC monitor that the whole system is now ready. That is more for test purposes probably than in a continuous real life situation. Well, this is all the code put together. Let's now again finally put it to the complete test again. Here we go, the train is coming, the sensor saw it, yeah, that's all fine, the LEDs are blinking, the gate is closing, and that is all quite like we expected. The train moves on, of course, and then finally it runs into sensor 2, which tells me that the gate should open again, and once it is fully open, then the LEDs will stop blinking. Yeah, they did. Well, this was it. This was 4 videos on our model railway crossing. And there's also a UK version. Please visit the blog number 21 for that. Thank you for watching, and maybe see you back in the next video, where we are again going to blink, but now in a very special way, which will also make us look at some code principles called an array and a for loop. See you back there.